if I had the equation x squared plus 6x plus 5 equals 0, well, let's actually back up a little bit. Let's change this to y equals. Okay? This is a quadratic that's shaped like a parabola. And this one looks like that. Yeah, I know. I have a master's degree in math, so you can trust me. So, if we have a quadratic that's set equal to y, that represents the entire parabola. What if I change this, and I throw out the y, and I put a 0? Well, we learned how to solve these. What do I know about this particular quadratic? Its factors. Signs are the same and both positive. So x plus and x plus. And I'm looking for the factors of 5 that add to be 6. Well, I really only have one choice. Do 1 and 5 work? Yes. 1 and 5. This is set equal to 0. So I know that x equals -1 and -5. What does this tell me? That those are the positions of the roots. So, when I took my quadratic that equaled y, and I threw out all of the y's except for y equals 0, I have narrowed this down to where the quadratic hits the x-axis. Those are called the roots. So by changing it from y to 0, I got rid of all of these points, except for the roots. Okay? Today, we're going to do this. Where is the quadratic greater than or equal to 0? Which parts of the graph am I going to keep? The one above the x-axis and I so wish you guys were being recorded by this microphone. But there's something important going on there. I'm going to keep everything above and at 0, including the roots. So how do I include the roots? Domain-wise, or intervals, I would use brackets. On the graph, what do I use? Filled in circles. Okay? So the solution to x squared plus 6x plus 5 greater than or equal to 0 is actually the part of the graph above the x-axis and the roots itself. Okay? So if I had x squared minus 5x, let's do minus 14 is less than 0. Well, let's factor this. X and x, what do I know about the signs? They're different. And the negative one is bigger. Are there factors of 14 that add to be 5? 1 and 14, 2 and 7. -7, +2. So my roots are 7 and -2. So if I were to draw the graph, does this one open up or down? Well, we look at this value here, and it's positive, so up. So here's 7, and here's -2, and the graph is going to look like this. How much of the graph do I keep? 0 and below? Not 0. Below 0. Why is it not 0? Because we say less than. So everything below, what symbol do I use to recognize that the x-axis doesn't count? Open circles. Yes. Yeah. Well, I'm priming you. We're still not quite there. I'm just teaching you some of the basics. So I don't even need the dotted line. Oh boy, they're all separate. I thought I could throw them out in one fell swoop, but I can't. So the graph does not include the dotted lines. It's just this lower piece. Okay? What if I had x squared plus... Oh, I better be careful. Um, oh, we need an inequality. Less than or equal to 28. So I need to move the 28 over so that it equals 0. So x squared plus 3x minus 28 is less than or equal to 0. X, what do I know about the signs? So minus and plus, and the bigger one is plus. So 1 and 28, 2 and 14, 3 doesn't work, 4 and 7, that's the last set. So positive 7, negative 4, so my roots are 4 and negative 7. So I have a root at negative 7. Is it going to be open or closed? Closed. It's included. So negative 7 is over here. And so I'm going to label this as negative 7. And then I'm going to label this one as 4. It opens up, and which part am I going to keep? Less than 0. So it's going to be the bottom half. You understand it, Jared. You're fine. Okay. If it was the other way around, if it was greater than or equal to 0, then you would just do these pieces. Okay? But the equations we're going to deal with today are much more complicated than just a regular quadratic. So you're going to be graphing them in your calculator, and then you just have to know, do I throw out the top half or do I throw out the bottom half? Yeah, it's not too bad. The tricky part is you have to remember, do I keep the roots or not? That's the hard part. Well, it's not hard, but so let's do one. I'm just going to make this up. Times the square root of, ooh, I better not do that. Let's do 3 minus x. We'll see if this works, because I have no idea. So, in your calculator, type this into your y equals. So, oops, I need the parentheses. X minus 4 times the square root of 3 minus x. Graph it, and my window's all messed up. How do I get back to the standard window? Well, you could do window and type it in, but I'm lazy. Zoom number 6 will take me back to the 10, 10, 10 window. Okay? So there's the graph. Oh. Where is that graph less than 0? Everywhere. So my root is 3, and all I really care about is the label on the x-axis. I don't care about the labels on the y-axis. So it's going to look something like that. Is that an open circle or a closed circle? Open circle. Right. Okay. For this particular problem, what if it said greater than, strictly greater than 0? There is no graph. So the answer would be never. Right? What if it said greater than or equal to 0? It's not true. It would be a closed circle on the root, and that's it. Does that make sense? So what if I had a graph that looked like this? Um, actually, let's do one. I think there's one in our book. Yeah, sorry. I know. Go to page 123 or just watch. Yeah, assignment's in the book. Okay, that function right there. Um, yeah. So x minus 2, and then x plus 3. Now, your calculator makes a mistake here, just like it did when you were graphing circles. It didn't actually touch the axis, but it does. So sometimes when a graph gets really steep and then stops, then the calculator freaks out and leaves a gap. So we can assume that that actually hits the x-axis. So my graph looks like this. 1, 2, 3, hits that, goes through the point 2, and I want to know where is that graph greater than or equal to 0. So what is my solution graph going to look like? So what part of that graph is bigger than or equal to the x-axis? Right, we have a closed circle right here. And then a closed circle at 2, and then this. Yeah. So all you need to do is draw the graph. Does it ask? Hang on a second. Um, okay, so we do need to state the intervals. So the answers are x equals 3 and the interval from here on. So 2 to infinity and what? Good. Bracket and parenthesis. That's how, so you'll draw the graph and then you'll state your answers in this form. Okay? Um, if there's actually a more complicated way to do this, which is not something you guys are required to do. So if it looks like it stops at like -2.5, oh, that's a -3, then just say it's -2.5. You don't have to be, you don't need to find the roots. What if I change this to be strictly greater than? How would that change the graph? So I would have an open circle on the left, which is, what is an open, a single point that's open? Nothing. Right. So if you take a point that is closed and you change it to an open point, it actually disappears. Because there's open circles have something above it or below it, and this one has none. And then it would change this to an open circle. So how would that change my solution set? The 3 would go away, and then this would be a parenthesis. So on this assignment, you need to draw the graph. So just graph in your calculator and then figure out above or below. Pay attention to open circles and closed circles. And then you need to write the x interval for which the solution exists. Okay? I only want you to go to number 15. Okay? No, that's when you're done, you can turn the assignment in.